All right, so let's see where it was. Yeah, it's work. This one. Okay, cool. Right, so now we officially started. And good evening, good afternoon, everybody. Hello to the guys watching on the YouTube. Yes, I'm talking to the cameraman. So the topic today is the Reactive Declarative UI escort. And before we begin, just a little bit ground rules. So firstly, yes, we are talking about Flutter Jetpack Compose Suite UI. Yeah, let's just move forward. And I also already mentioned, right, really appreciate you guys to be here because I am sandwiched by all the gurus. So really appreciate that. And also, if you want to take out the camera, point to the slide, this is the moment because this slide is available online right now. This is the QR code. So you don't have to take the picture of the slide later and just focus on listening and thinking, etc. Yeah, really like that. So yes, that is my appreciation for you to be here. Now about me, you can call me Sinh. Well, my full name is quite long. It's easy for me to miss, but for long for others. I've been in European in Finland for last 10 years. I just came back to Vietnam last May actually. And yes, so currently I'm the engineering director at Inspectorial, and I myself is a Flutter advocate, and this one is my Twitter handler. About the company quickly, because I know you are here for the technical stuff, not about the company. We can talk about company later, but still I am obliged to have a quick introduction. Yes, we are a startup. We are 13 quarters old. We don't count the years, we count the quarters. We serve Fortune 100. So top company, big company, and we always looking for talents, not only developers, but also any other range of talent. Obviously we have the open position on that, so just if you think the company is cool, if you think I'm cool, please apply. And we have the offices all around the world, in Asia, in Australia. Well, I mean, we have the people all around the world, and some other offices also all around the world. Yeah, this is okay. Now, let's go to the main thing. Already introduction, right? The concept, why it's trendy, and why this is the healthy competition that benefits both the components inside, but also the user, in this case, the developer. So, concept review, yay, it's like back to the classroom of university, right? We learn about the concept, reactive, declarative, and escort. Firstly, declarative. So what is declarative? And some things, the declarative might not be escort or UI. So it's simple. Imperative is not declarative. Imperative is the opposite of declarative. In the imperative paradigm, I am telling the instruction step by step. Okay, first step you do this, next step you do that, etc. But then with the declarative, we tell what the result, actually what the input is and what the result that we expect from, and leave the algorithm to the compiler or the runtime, etc. So it's basically just an abstract layer on top of that. For an example, for every Monday, Wednesday, and Friday, my wife have the instruction list that I have to follow. So yeah, first I have to open the rice cooker, put the rice in water concurrently, and press the cook button. And there's the future, or if you are familiar with the JavaScript, is the promise, right? And the same thing here. So, and when both the futures resolved, then I present the future values to the tables. So I mean, it went well for a while until one day one of the two futures got rejected, right? And we didn't know what happened. Here's a stack trace. So we have to go back and have the debugger, right? So we go step by step. First step, nice. Second step, okay. The next step, right. So the cooker object has the encapsulation and they have the internal state. And we didn't check the internal state. So even though we follow the instruction, we have the same input, but sometimes the output is different. It's because the object state, internal state. Right? Now, if the instruction has been declarative, this would be the one. So a table, and then inside the table we have meal. With the meal we have food rice and soup with veggie and tofu. And no matter how, maybe I can call somebody else, hey, can you get the order for me? It is up to me. As long as we have this on the table, my wife's happy, right? And this is just a funny example. Now the code example is here. So because if you have been doing Android, I'm 99% sure that you have been doing declarative UI before, and that is the XML declarative. However, XML here, it is declarative, but not reactive, and not as code either. Also, when you do the Android, you have to choose either do this XML as a declarative, or you have to sacrifice this one so that you can do the programmatic UI. So if else and then create child, create button, append button to parent child. That is the programmatic. We will go back to that later. Now next, reactive. When I talk about reactive, what is your first idea in mind? Anybody? No? Reactive? I'm sorry? RX Java, yes, RX Java. But let's have even more concrete. Let's not talk about code, let's talk about something else that also reactive. Sorry? Screen. Stream. Well, stream is also code. What I have in mind is actually Excel or spreadsheet. Because, I mean, it is basically the idea of reactive, right? So in cell C, you define the expectation. The cell C is that, okay, I want it to be the sum of cell A and B. And whenever A changes, C changes, right? Whenever B changes, C also changes. So if you have to think about reactive in one slide, this is the slide. Yeah, maybe we can talk about yeah, let's not talk about this, but so maybe you can talk about reactive. Maybe you can talk about unidirectional. In Android is the MVI, right? But spreadsheet itself is the first that can come to your mind. And by the way, so on the MV star with the two-way binding, that is not reactive. Keeping in mind that later we might go back to that. Now, reactive with imperative UI, right? So as I said, the code can be one but not the other, and we at the end of this slide we go with the code that has all three attributes. So here is the reactive stream but with imperative UI. If you think it's too much, let's focus on first. Here is the reactive stream. Basically, I just listening to the stream, and then if you are like gamers, you should know this is the Konami code, right? So I have some operator on the stream, and then I don't care whether the data is now or data is in the future. I just define all the operator, all the things I want, and then when the data is coming in, it just do what I want the result to be. So this is the reactive stream, and here is the imperative UI that we mentioned before. This is more like from the web, not like Android, but you get the idea, right? So you create from the object-oriented manner, and then you set, you get, you append a lot of things here. Right, now that is the reactive. Now let's go to S-code. So from my opinion, UI S-code is programmatic UI on steroid, right? What does it mean? First, programmatic UI. Programmatic UI is the imperative UI that we have seen before. So we have the access to full language features of the same, in a single language. You don't have to use several languages. You can have if, else, you can have like if with coroutine, etc. On the language feature, you can use it, and you don't have to learn another concept, another syntax, etc. And here is an example, a counter example. In one snippet, you have to use 3 languages, right? One for, I think, layout, one for decoration, and one for reaction on the code. Now, let's get back to the UIS code. So I mentioned before that the UIS code is programmatic UI, but more than that. Why more than that? Because UI code is a little bit different from logic code. And if we want to have the UI code, we have to have some additional support, either through the DSL, so domain-specific language, or some really close collaboration between the UI team and the language team. That is what's happening with Dart. And with the DSL, usually we have the intermediate compiler, or we call it transpiler, right? And with the vanilla language, then we just use ACID. Now, why is it trendy? Because, well, I don't know about you guys, but I'm really lazy. If I am paid for the same work, I mean paid the same amount of money, but I have to do less, like half of the work, I really like it. And if I am paid I'm paid the same money with somebody else doing my job, then yes, I love it, right? And if I have to walk for 1 hour, but someone give me a lift, like basically just help me out, then yes, I will take it. And finally, if something makes me smarter without having to learn, having to study in RMIT for 4 years, then of course I will use it. So here, because we can achieve the same result with less code, with the things that basically done for us, faster development cycle, and cleaner, more testable code, that's why it is trendy. Now let's go to each. Why it is less code? Because there's a lot of abstraction layer already that we don't need to focus on. We just need to focus on the logic, the business logic that the project manager, that our boss care about. They don't care about, let's say, memory allocation, right? So if we take a quick history of programming language, the first programming language, basically you have to write it in 0 and 1 bit. Assuming that we have a Hello World app in release mode, it takes about 10 megabytes. And assuming that I can code 1 byte per 10 seconds, and I code it 24/7, no eat, no sleep, it would take me 3 years to write the Hello World in Android app, and another 8 months for the release code, because the release of Hello World, I think, is around 2 megabytes. One abstraction layer up is the assembly language. But still, it's just mapping one-to-one. You don't have to write in 010 anymore, but then you have to do the instruction code. It's more or less like English, but it's still 1-1, and it takes you kind of the same, 3 years and 8 months anyway. Now, up one level, we see that the language now is CPU independent, right? So this August the 1st, Play Store requires you to submit, if you submit the native application, they require to have both 32-bit and 64-bit. We don't have to do it twice because the compiler, the abstraction, do that for us already. And also, in the early high-level programming language, you have to do the memory allocation yourself. But now, thankfully, each job is done by the garbage collector, and also threadings. Well, I mean, I myself has a lot of pains with threading and synchronization, but one more abstraction layer on top of that is the coroutine, right? So that's to prove that with each abstraction layer up, we have less thing to worry about in terms of the technical, in terms of the mental, but more about the business logic and the testability of our code. Now, if you don't believe me that more abstraction layers means faster development, then let's have some proof, right? Because Jetpack is still in technical review, I could not find any reliable source. Comparing Flutter with Android SDK is, well, frankly not fair, right? So let's see Swift UI versus UIKit, and there's the YouTube video recording that by Paul Thompson, and I really recommend that. Basically, this is what he was trying to achieve in both the UIKit and the Swift UI. So 3 screens, one list, one detail view, and the alert view, right? So the result is that it's about, this is the time and the size, the number of lines of codes for the relevant part of the UI. So the time is like 2/3, and the size, the line of code is 1/2, so half of this. And remember that this Swift UI, if you watch the clip, he already do something extra that not required by the original scope, but still 2/3 and half of what text the UI did. That is the why is less code, but then achieving the same. Now talking about the optimization, why? Because we just declare what we want, and it's up to the compiler, up to the runtime, up to the machine to do that. And with every new release of that abstraction layer, they can have some optimization. And one of the example is the React 7 time slicing. So it may require some web knowledge about the single-threaded language to understand this optimization. But the point is that the optimization, the algorithm is taken care of by the abstraction layer. You should focus more on the business logic rather than the algorithm to solve that problem. Why we have the faster development cycle? Well, because if we have less code, then of course we have shorter development cycle, but also because of other part, for example, the hot reload. If you were using Reactive, hot reload is really great in terms of getting the feedback and then making your developer experience much better. And also because with the imperative, we have the flow, right? And then we put the debugger point. So first step, second step, next step. But then that debugger point is more applicable to the logic. With the UI, we want more like an inspector. The inspector, if you are familiar with the web, so you see that, okay, this button, where do I have that button? Here is the example. So let's just say I want to see this, so I click on the inspector of this text box, and then it will show in the tree and also in the code. It's kind of hard. I mean, I think it's technically feasible to do this in imperative, but with the declarative, it's much easier to implement this tool. And also, for example, if I want to do this, then okay, where is the code? Should I look for? Should I change to make this button from blue to green, for example, right? Now, what do I mean by cleaner, more testable? Firstly, well, it's cleaner because we have the reactive is like unidirectional, right? And so far with the MVP and the XML, usually we have a lot of MV star, and these are more like two-way binding. Or if not two-way binding, it's still the bidirectional. So with the reactive is one-way only, and with one-way, right, is similar to traffic jam. It also applies to data. So half of the thing, so it's less data traffic jam, and it's also easier to separate the business from the platform or the technical. And what can go wrong? Because again, here, cleaner, if done right. So what can go wrong? For example, you may have too many states, internal states in your UI. Remember the cooker example? If we have the more internal state you have, the more explicit it becomes and harder for other people to collaborate with you. And also, if we have too many logic entangled in the UI code, why? Because we really deal with it. Where there's a logic, there's a unit test, and we don't want to test the UI a lot. The UI should be dumb UI, right? So we should test, okay, if I give you this, you render this kind of pixel, and that's it. Logic, well, give it out of it. Now, so yes, these things, and that's why it's trending, right? Deservedly so. Cool. So where do we go from here? Well, it brings up the competition, because once upon a time, any developer want to go with this paradigm, they have to use React Native, and that's it. There's no other ways. They basically have to choose between the reactive declarative UIS code, or they have to choose the performance. There's no other way, right? But now it's different. The time is different. Now we can achieve. We can have both. We can still have the nice developer experience, but still with the native performance. And even more than one tool to do it. For example, if you are developing Android, you can either choose Flutter or Jetpack Compose. Or if you do the iOS only, then you can choose between Swift UI and Flutter. Also, as Mr. Bean famously said, that where there's a competition, there's a market. And by the way, as we are on the topic of the quote, Lý Thái Tổ Hoàng đế also said that don't fucking believe every quote on the internet just because it has the poetry next to it, right? But a little bit side topic, so let's go back here, right? So where there's a competition, there's a market. Because it means that there's actually more and more people are coming into this reactive declarative UIS code. That's why there's competition. That's why people invest in making these tools, making these paradigms more easily accessible, more tools, more support tools for that. And it also means that the switching cost between, let's say, from Flutter to Jetpack Compose is smaller. In the future, if you want to switch from one to the other, it's not that hard anymore, because because in the past we have someone ask, hey, I'm so used to doing XML with the MVP or MVC. How can I do it in Flutter? Because I'm used to that paradigm already, right? And I just find the stream and the reactive functional programming is too hard for me. Anything I can do similar, but in Flutter, because I want Flutter in the cross-platform. Well, now, because everybody is doing the same paradigm, switching the technology is much easier. So, in conclusion, reactive declarative S code has already been a trend, right? It started by React.js, but then within the mobile is the React Native. So my advice, my personal opinion is learn it, embrace it, and utilize it. Now, for anyone who tried, by the way, anyone heard of Flutter before this talk? Hands up? Like more than half, right? So if you want to try Flutter, then I think Flutter is now really in the sweet spot, because as said, React Native suffer performance problem, especially on Android. The performance on iOS is quite acceptable, but Android is like crazily bad. Swift UI is still better, and even if it's reached stable, it still requires iOS is 13 or up, so it may be 1-2 years from now until it reaches mainstream. Jetpack Compose is still in technical review, so you can play with it, but then maybe it's not safe for your work or your position if you recommend Jetpack Compose at the moment to your boss. Flutter, on the other hand, is already reached 1.0 last year. Right now, it's already at 1.7, and it doesn't use any DSL. You don't have to learn one abstraction level is just writing down that. And also ask the right question, because should I use Flutter with MVP or MVVM is the wrong one, really. So it is a bug, not a feature, that Flutter does not use XML layout. And I think it's also one of the frequently asked questions that is officially on the Flutter team. So, yep, thank you. And I'm not sure if we still have time, because actually in Flutter you can still do the imperative programming. And I made the Flappy Bird game using Flutter just to see how imperative programming would be in Flutter and how performant the Flutter is. So how much time do we have left? Or maybe we can compare the Q&A with the demo to see how it goes. So meanwhile, please, anybody have a question? I will just see how we can have this up. So questions?